Alrighty. We're gonna be working on some balancing of not balancing of equations, but forming of, what are they called? Forming of chemical compounds. So like in a test or something, if it says, or just on a packet, test, homework, whatever, if it says, like, I don't know, sodium chloride, how do you know to write what sodium chloride is? So, first what you do is pull up your lovely periodic table, and what we do is, we look for sodium, so Na right here. So that means we have sodium. And then, where'd it go? I lost it. There it is. And then chlorine, that's the chloride. So if it's an ionic compound, which is anything with a positive electric charge plus anything with a negative electric charge, the second term ends in an "ide," and there is no suffix. So there's no like di, there's no tri or quad or hepta, whatever the hell they are. So, yeah. So sodium chloride, it is Na and Cl. Those are our two components. Now, if we look at the electric charges of both of those, this is how you know how many you're going to need. So if we look at sodium, it is in the ones, one right here. If we look at chlorine, it is over at 17. Now, how we like to do these is, where are you? Not ionization, no. You? No. Electron configuration? Yeah, there we go. So, well, no, that's not what I want either. Hold on, let me figure this out. Electronegativity? No. Well, shucks. Not really sure. But how we normally do it is it goes +1, +2. These guys are weird. +3. I don't remember what these are. But then it's 0, -1, -2, -3. I think these guys are also an edge case, because I don't remember if they're +4 or -4. I think they're both. I think they're +4 and -4. Which is weird. That, if you're taking AP Chem, I'm sure she'll explain that to you. Your teacher will explain that to you, but I don't know. So, we look at sodium. It is in the ones, so it is a +1 charge. We look at chlorine. Since these are 0, these are -1. So that means chlorine is a -1. So, that means +1, -1. Now, what do you notice about those? +1, -1. They just cancel each other out. So, that means sodium chloride is just NaCl. Perfect. So, if we move on to something like, what would be two good ones to, let's just pick. We'll go with magnesium. Magnesium nitride. I think is that a real thing? Let's find out. Hold on, the magnesium nitride. Magnesium nitride is a real thing. Oh, that's not okay. Magnesium nitride. Sorry, this video is going to be so all over the place. It's like 11. Yeah, it's almost midnight. Let's pull up the time. Yeah, it's almost midnight. So this video is just kind of me doing whatever. I don't know if magnesium nitride is a real thing, so we'll do like magnesium sulfate. Yeah. Sure. So, I know magnesium sulfate's a real thing. So if we have our two components, in this case it's magnesium and sulfate, you'll have your if you look on you might have to memorize this, but sulfate is a compound in and of itself that is sulfur and then 4 oxygens. So it's SO4, and magnesium has a +2. If we go back and look at our periodic table, there's a +2 right here. And then if we have 4 oxygens and a sulfur, that sulfate is a -2. So again, those two cancel each other out, and you're left with just MgSO4, magnesium sulfate. Now, if we do something like, we'll say magnesium hydroxide. We all remember what hydroxide is. Oh, hydroxide. Magnesium, as we know, is a +2, and hydroxide, we can figure that one out. Oxygen -2, hydrogen +1, so that means hydroxide is a -1. Now, what we can do with this is we can, what my teacher liked to say was we can cross and drop, which is where we take this number and this number and bring them to the front of each other's, of the opposite thing. So in this case, it would be bringing the 1 in front of magnesium, so 1 magnesium, and then 2 OHs. It wouldn't be 2 OH2. No, it's not like that. If it was like that, then the 2 would have to go in front of there. With this, you put it in parentheses, and then write the 2. Just like you're doing a subscript for any other element or something, but you just have it for a compound now. And then this is what magnesium hydroxide would be. +2, -1. And we can do this for, I'm just going to make something up right here. These are not the real charges of these. But if we said like, we'll say magnesium. We know magnesium is a +2. So we'll roll with that. Magnesium +2. And then actually, no, hold on. We'll pull something that is a -3. Phosphorus. Magnesium phosphide. Magnesium phosphide, so -3. I need to do a different color. Shoot. Mg +2. Phosphor -3. So then we do the same thing, cross and drop. Bring the 3 to the front of there. Bring the 2 to the front of there. And then you are left with Mg⁻3 phosphorus sub2. There you go. Cross and drop. Pretty darn simple. Yeah. This is how you form basic chemical compounds. Obviously, it can get more complicated, but this is the basics of using the electrical charge to determine how many of what you need. So, thanks for tuning in to my midnight ramblings. So, goodbye, thanks for stopping by, and happy studying.